Hello everyone, welcome again. Today our topic, as I already told you, will be applications of inductive effect. In the previous lecture I told you definition part and two types of inductive effect, negative inductive effect and positive inductive effect. Today we will discuss some applications of inductive effect. Let us start. Applications of inductive effect. Applications of inductive effect. So, as I already told you, inductive effect has many applications. In organic chemistry, it affects many properties of organic compounds. Today, we'll learn about some of its applications. Number one application is relative strength of organic acids. Okay. Acid, we all know, is that substance which gives H positive ion in water, which releases H positive ion in water, and itself is converted into conjugate base. An acid, after it donates H positive ion, is converted into a conjugate base. Okay? Whenever you see any organic acid, when it is dissolved in water, it gives H positive ion, one or more, and itself it forms a conjugate base. Now, which organic acid is stronger and which organic acid is weaker? We will compare their relative strength on the basis of inductive effect. We will see what is the role of inductive effect in making organic acid stronger or weaker. Let us see. That organic acid is stronger. That organic acid is stronger, whose conjugate base is more stable. Stable here means weak or less reactive. Stable means weak or less reactive. Okay, so that organic acid is stronger acid whose conjugate base is more stable, is weak, is less energetic. It is common sense. That organic acid will become stronger, which readily gives H positive ion. Why? After giving H positive ion, it attains stability. So conjugate base should become more stable. To make this statement clear, I will write two organic acids and we will compare their relative strength on the basis of inductive effect. Is this clear? Yes. Let us write two organic acids. Two organic acids. First organic acid is this one. This is CH3 C double bond OOH. It is called ethanoic acid or simply acetic acid. Acetic acid or ethanoic acid, IUPAC name. Second one I will write here, it is CH2Cl. This one is called chloroacetic acid. Chloroacetic acid. Both are organic acids. We will see which one is stronger and which one is weaker on the basis of inductive effect. So, in water, if it is dissolved in water, and if this one is dissolved in water, it gives a conjugate base, acetate ion, and second one also, when it is dissolved in water, it forms a conjugate base. It forms a conjugate base. So we have two types of conjugate bases. Conjugate base first and conjugate base second. Now we will compare the stability of conjugate bases. If the conjugate base becomes stable, acid becomes strong. If the conjugate base becomes unstable, reactive, acid becomes weaker. Let's try to analyze what is the difference between two conjugate bases. Here, negative charge on oxygen, negative charge on oxygen. Here carbon, here carbon. Here double bond oxygen, here double bond oxygen. In this, we have methyl group. And yesterday I told you methyl group exerts positive inductive effect. So, plus I effect. Methyl group exerts positive inductive effect. It is adjacent to functional group carbon. Let us analyze second conjugate base. It is chlorine. It exerts minus I effect. Chlorine exerts minus I effect. Minus I. Okay. And what's plus I? I will give a reminder. Displacement of sigma electrons towards carbon. What is minus I? Displacement of sigma electrons away from carbon. Now what will be the effect of this plus I and minus I on the stability of conjugate bases? Try to understand. This is electron donating group. It will increase negative charge on oxygen. Yes. And this is electron withdrawing group. It will decrease negative charge, electron density on oxygen. What will happen then? If negative charge on this oxygen increases, it becomes reactive, energetic, unstable. Got it? I will repeat. If negative charge on this oxygen increases, it will become more reactive. It will combine with H positive ion and give back acetic acid. Yes. So, increase in negative charge on oxygen will make conjugate base unstable. And when conjugate base becomes unstable, acid will become weak. Got it? Yes. Here you will see, because of minus I effect, negative charge on oxygen will decrease. So conjugate base will become weak, less reactive, and more stable. And when conjugate base becomes more stable, acid becomes stronger. Now, which acid is stronger? First ki second? Second one, chloroacetic acid is stronger acid than acetic acid because of negative inductive effect of chlorine, which withdraws sigma electron density away from carbon and makes conjugate base more stable and increases acidic strength. Now I will write this explanation. So here I will write chloroacetic acid is stronger acid than acetic acid. Okay. Now why? That why part I will also write. Why so? Reason is chlorine exerts minus I effect. It withdraws sigma electron density, okay, away from carbon. Okay, this decreases negative charge on oxygen. Okay, when negative charge on oxygen decreases, stabilizes conjugate base. Got it? So when the conjugate base becomes more stable, then acid becomes strong. Got it? On the other hand, in acetic acid, methyl group that shows positive inductive effect, that increases electron density on oxygen, that makes conjugate base unstable reactive and decreases acidic strength. I hope it is clear this part. Why is chloroacetic acid stronger acid than acetic acid? Yes. In case of any doubt, please write to me in the comment box. Okay. Now I will write one more statement. In general, more the number of groups showing minus I effect, stronger the acid, stronger the organic acid. Or you can also remember it, stronger the minus I, stronger the acid. Stronger the minus I, stronger the acid. Another statement, more the number of groups showing positive inductive effect. I told you earlier, tertiary butyl, isopropyl, ethyl, methyl, more the number of alkyl groups in an organic acid More the number of groups showing plus I effect, weaker the organic acid. Weaker the organic acid. Thank you for today. Now, on your part, you practice more such numericals in the NEET exam, in the competitive exams. Such questions are asked. Arrange the following acids in decreasing acidic strength. Arrange the following acids in increasing acidic strength. Making use of inductive effect, you can arrange them in decreasing order or increasing order of their acidic strength. Thank you and subscribe my YouTube channel.